we're going to look at functions in this video and what makes something a function. So one of the things about functions is that each x value is going to have a unique y value. Now, that may not make much sense to you, but what that actually means is that the x values cannot repeat. And so when we look at something on a graph, we can also use what we consider the vertical line test. And where we get to graphs in a moment, I'll explain what that vertical line test is actually doing. But when we look at, let's say we just have a set of ordered pairs. We have 3, -1, 4, 6, 7, -8, and we have 3, 9. Now, in this particular case, as we look at our x values, we only have to look at our x values for right now. You'll notice that this x value and this x value repeat. So this particular set of points is not a function. And if we were to draw it on a graph, these 2 points would be right above each other. So it would not pass what we consider the vertical line test. So let's go over to an actual graph. And if I'm looking at just some points on a graph, what I'm going to do is at every value, I can draw a vertical line. And as long as it only touches my points one time, then it will be a function. But let's say that I put a couple of extra points on here. Let's say I put here and here. When I go to draw my vertical lines, notice this vertical line will touch 2 points. So at this now, this is not a function. In order for it to be a function, it has to pass the vertical line test, and therefore it has to have unique y values. If we come back over here and we look at a diagram, and this diagram is going to have our x values here and our y values here. And we have x values of -2, -3. And we have y values of 4, 6, and 7. And I'm going to draw lines. So this 2 is going to go to the 4, and the 2 is going to go to the 7. The -3 is going to go to the 6. And I want to determine if this is a function or not. Anytime you have a diagram like this, if you're not sure what these lines represent or you can't see it, write the ordered pairs. We have -2, 4. We have -2, 7. We have -3, 6. Because all I'm doing is following those lines. Since the -2 repeats, 2 values come off of it, it is not a function. So we have to be a little bit careful. Let's look at one where it is a function. Let's look at if we have, we'll say 1, 3, 2, 3, and 3, 5. Remember that whenever I'm trying to determine if it's a function or not, I'm strictly looking at the x values. I don't care if these y values repeat or not. I'm strictly looking at these x values. These x values are not repeating, so yes, this one is a function. Same thing if I look at a diagram that has x values of 4, 6, -2, 9, and I'm sorry, those are your x values. Your y values of 2 and 0, and I draw my lines. Okay, well, notice each x value only has one line coming off of it. So my ordered pair would be 4, 2, 6, 2, -2, 0, 9, 0. None of my x values repeat, so this is a function. So when we're looking at this for graphs or ordered pairs, it's fairly straightforward. When we start looking at the equations, we have a little bit more difficulty. But I'm going to tell you something that's going to make it a little bit easier for you. Something that looks like this is a function. Because if you think about y is equal to 2x plus 6, that's going to be a straight line. Something that looks like this is a function. And you'll notice that I've changed the exponent of my x's. Even if I were to do y is equal to 4x to the third minus 7, that would still be a function. So again, I'm changing that value of my x exponent. Whenever I change the value of my y exponent, then it's not a function. So the big thing with functions is that your y value has to be raised to the first power. If your y value is raised to any other power, it's not going to be a function. So try determining if things are functions or not, and then let me know if you have any questions.